Let's examine the function f of x equal to x squared. We will begin by constructing a table that will pair corresponding x values and function values. We will find the function values associated with the x values, -2, -1, 0, 1, and 2. The function says that we are to square these values. When we square -2, the result will be 4. When we square -1, the result will be 1, and so on. When we graph these ordered pairs, the result is a parabola. Now let's look at what happens when we add 2 to the function f of x equals x squared. We will find the associated function values for the same x values that we used in the last table. The result is that 2 will be added to each of the function values in the previous table. So when we graph this function, each of the corresponding values on the function f of x equals x squared is shifted up by 2 units. Let's look at what happens when we graph the function f of x equals x squared minus 2. We will again use the same x values as we used in the last 2 examples, and this time the function values are 2 less than each of the values in our original function. So when we subtracted 2 from each of the function values, the result was that the graph was shifted down 2 units. So let's make some vertical shift generalizations. Suppose that some constant c is greater than 0. To graph y equals f of x plus c, we shift the graph of y equals f of x upward c units. In this case, that constant was 2. To graph y equals f of x minus c, shift the graph of y equals f of x downward 2 units. Again, in this case, that constant c was 2.